So you are given a sigma notation. A sigma notation, we spoke about it, which is a Greek letter, which means the sum. Now let's talk about the sigma. What is the sigma here? Now, instead of giving you a series, I will give you a sigma notation. A series and a sigma notation, and they're exactly the same. Remember, what does the series say? The series says which the sum of, I can add the following. It's a sequence, I can then add and then I can then write it. Let's write this one. I have 1 all over 2 plus 1 all over 4 plus 1 all over 8. Now, this one, it's a series which doesn't have an end. So it doesn't have an end. I don't want to call it an infinity series. So it's a series which doesn't have an end. Now, as soon as you have your series here, instead of writing it this way as a series, I can then write it as a sigma notation. Instead of writing it as a series, I can write it as a sigma notation. What is a sigma notation? A sigma notation, you can say which it's a simplified version of a series. Now, what you have inside your sigma, you have the sigma sign, which represents the sum. Here you have Tn, which is the general term. Now we know how to get the general term. How do you get the general term of this thing here? You first have to find out what is it, geometric or arithmetic. Is it geometric or arithmetic? It looks like what? It's a geometric. Now, if it's geometric, then you look for R. If you look for R, you will have 1 all over 4 divided by 1 all over 2. What you get? 1 over 2. 1 over 2. And then you say which R is going to be 1 all over 2. And then you will then say, what is Tn? Tn is going to be given as, Tn is going to be given as 1 all over 2 multiplied by 1 all over 2 and minus 1, like this. Yeah. So this is the general term. So what am I going to put here? Here, I am going to put the general term, which is going to be 1 all over 2, 1 all over 2 to the power of n minus 1. And then here, what am I going to put here? Okay, you need to be careful here. Learners tend to make a mistake here. Now here, I'm going to put the value that I'm going to substitute to get the first term. It is not, which is this one, it's position number 1. It's not a position in this thing. It's the value that you substitute to get the person who's going to be in position number 1. And then here's what is interesting here. You see, again, I said n here. And then here it also has what? N. If it's k here, if I put k here, I can also put k. If I put k here, I should also come and put which. Starting when k is 1. So what does this thing say? It says, determine the sum of the series. Determine the sum of the following series. Starting from when n is 1, if it's n. Starting from n is 1. Up until you get to, they will give you a value here. They will say maybe up until to 28. So what are we saying here? Calculate the sum. Starting when n is 1, we need to put so that I'm not confused. We have n. It's n, it's n. If it's n, it should be n. And then so yeah, you are calculating the sum of the series starting from n is 1 up until you get to 28. So basically, how does this thing work? What are the key things? I'm saying a sigma, it's a simplified version of a series. Instead of me giving you a series, I can give you a sigma. Why a sigma? A sigma gives you the general term. It doesn't give you the series. But remember, if you have the series, you can go and determine the general term. Okay? If you have the general term, you can then determine the series. It's vice versa. As long as I know what is Tn. They're talking about Tn. If we do this one, so the first thing that we should know about this is that we need to know we have to know how to determine the first 3 terms if we are given a sigma notation. How to determine the first 3 terms? Simple. You start, I think I said, remember what is this here? This is the value that you substitute to get the first term. It's not a first term. It is the value that we substitute to get what the first term. So in other words, what am I going to do here? I am going to tell them what I have 3, and then I have 1, 0. Instead of t, I'm going to put 1, 0. Because this is the value that I substitute to get the first term. And then it says 0 minus 1. Plus, this is going to be our term number 1. So at the bottom of the sigma, you're given the value that you substitute to get the first term. Now, after 0, what is the number that follows 0? The number that follows 0 is going to be 1. Then you come and say you have 3 multiplied by 1 minus 1. This is going to be the value that you substitute to get the second term. Plus, you go to term number 3. How to get term number 3? You do it consecutive, starting from the value that you substitute to get the first term. And then you do it as a number line, but after 0, what follows? It's 1 again. After 1, what follows? So it means you're going to sub 2 now. You have 3 multiplied by 2 minus 1. If you give me 3, I'm happy. And then after that, you say plus dot, 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 up until you get to this part here. This is the value that we substitute to get the last term. It is the value that we substitute to get the what then? The last term. So what am I going to say? I'm going to say it's 3 multiplied by 99 minus 1. And then you have generated your series now. So what I'm going to have? 3 multiplied by 0, you get minus 1. Right? So what does our series say? It says minus 1 plus 2 plus plus 5 plus dot dot dot. What do we get? It's the last term. 296. Now look at this. This looks exactly like what we've been doing before. We had such series. It's not the first time Sivan a series angel. So we did have a series like this one. Then they say calculate the sum of the series. It has a start, it also has an end. Okay? So even this one, it's just with, instead of me giving you the series, I give you the sigma, knowing which from the sigma notation, you can give us the series. And then Elena should be able to go from a series to a sigma, from a sigma to a series. But for today, what we're interested in is to go from the sigma to a series. We're going from the sigma to what? To a series. Now, once you have the series, then you need to know what kind of a series it is. I know we don't know, they didn't say. We'll just have to find out what kind of a series it is. Check here. If we say this one subtract this one, what do we get? We get 3. This one subtract this one. What kind of a series is this one? Wow, it's an arithmetic then. Now, if it's an arithmetic, then it means which I can then calculate Sn of an arithmetic system. I can use the formula that says n all over 2 a plus l, because I know what is the last term. Now, what did we do before, if you remember correct? That's what we did. We calculated the number of terms. Again, we wanted to know how many terms are here in the series. How did we do that? We said this is the last term. Again, you can still do that, man, if you want to. One of the simplest way. Sigma notation can also give you the number of terms. How to get the number of terms from a sigma notation? You say the top, whatever is written at the top of the sigma. I'll show you both ways so that you will decide which one is fine. Let's start with the one that we already know from earlier grades. If I was, after generating the series, I would then say, what is going to be Tn? I will say Tn is going to be given as minus 1 plus n minus 1 multiplied by 3, like this. And then I will have something like this. Minus 1, this one multiplied by this one multiplied by this one, plus 3n minus 3. And then it gives us 3n minus 4. Like this. And then what is this? This is also Tn, which is the last term. This is our Tn again. And then you come and put, okay, here we have 296. Take this one to this other side, it says you are going to have 300. Which is going to be the n. Divide by 3, you divide by 3. It says n is going to be. So there are 100 terms in. And then you should be careful, they are not 99. They are 100. So now what are you looking for? You're looking for S100. So you're looking for the sum of the first 100 terms. Now, what is the simplest way in which this thing could have been done, Rapelo? Is for you to say this. You go on your sigma notation. On your sigma notation, you say you have whatever is written on the top. So number of terms. which is its n. It's just confusing if they start to use n and n here, because now you don't know which n is which one. So how do you get the number of terms? Number of terms you say is the top one. What is the top one? 99 again. 99 minus the bottom one, whatever is written at the bottom. In this case, it's 0, and then n plus 1. It's top minus the bottom plus 1. And then what are you going to get here? So you will decide which one is best for you. But top minus bottom. And then we look for S 100, which is going to be 100 all over 2. What is the first term? Minus 1 plus 296. What do you get as your answer? Is the last term this one? We know this one is the last term. Yeah, if you know that you can only use this one if you know the last term. Yeah, n is the last term. Or it can be written as Tn. What are you getting as your answer?
14,750.
14,750 like this. Yeah, and then you should be done. Activity 8. And then I thought about those who are done. Let's give them something else.